Hi everyone, my name is Manish. I'm a platform architect in Intel's data center security product division, and I'm excited to present a project talk about Intel's open security controller. So here's a legal disclaimer that Intel wants us to display. And so let me step back and talk about what is a business problem. I mean, why are we doing this? And I have like three perspectives, right? So one is as we see around this week, and we've been hearing that enterprise operations and end users really want to start adopting OpenStack, right? And there's a lot of things that are happening to bring from a business perspective, reduce costs, increase agility, and all that. And amongst other problems, when a lot of the discussions happening in the last few, like today and tomorrow and next few days are going to be covering a lot of those, and Intel's addressing some of them. But one of the things which are also critical from that perspective is the security part, right? So from an end user operations perspective, how do they provide the security in a similar fashion that they have been doing for their current environments? So that's one challenge. Now, secondly, if you're from a perspective of a service provider, whether you're a cloud service provider or you're like a MSSP, or if you're just like telco connectivity service provider, you want to be able to offer security service as an add-on, and you should be able to do it on demand, scalable as part of a value-added service. And today it's not easy to do that in OpenStack. And then if you're a security vendor, you want to provide the same solution that you are providing on other environments on OpenStack for your customer. However, you have to do several point-to-point integration, and you have to in this rapidly evolving SDN technologies. And it's like a high barrier, right? Because you're doing multiple integrations, and it's going to cost you at the end of the day. So why is Intel doing this, and what is the intent, right? So the main purpose for Intel right now is to accelerate the adoption of virtualized security function for this project. And then the other one is, being able to, how do we do it, is to deliver seamless integration between virtualized security functions and the SDN controller. And I'll go more details into as we go in the next few slides. So from a technology perspective, what we have seen is, we have seen evolution in data center from a traditional hardware, where we used to have the paradigm of one application per system, to where we have discrete compute, network, and storage applications, storage devices, and the traditional hardware, to a virtualized one, where we are going into one application per virtual system, and we're virtualizing abstracting the hardware, and going into the software-defined data center, right? In the software-defined data center, the application defines the system, and the whole storage, network, compute become nothing but a resource pool, and you're abstracting the data center. So how do we provide security in this, where we are going into this software-defined infrastructure? If an intelligent scheduler is taking application and then scheduling it on top of this resource pool, how does it do that in a scenario where how do you provide security on top of that? So something has to really automate. You bring the intent at the beginning, how do you protect your workload? How do you protect your security or provide security on your application? And then something has to completely orchestrate all that into the data center, right? So what is this role of the security controller in a data center and this type of environment? So the so-called software-defined security orchestrator. So first and foremost is automation orchestration of the security functions themselves. So as we said, at the end of the day, we want to be able to automate security in a way that we are going to be available for the software-defined infrastructure. So taking some of this security functionality, like for example, multi-vendor, whether it's IPS, next-gen firewall, or any of those security functions, being able to map those and automatically orchestrate them into the infrastructure. The second is the centralized coordination of the security policy. Again, over here, we're coordinating the policies as is applies to our infrastructure, but we're not really managing the policy themselves. So the IPS manager is still going to define what a signature means, or if it's a next-gen firewall, it's still going to define what the application control policies are. What we're doing is really coordinating the policy as it applies to the workload dynamically as the things are changing. So as we get scheduled, and I'll talk more about this later. The third one is we're interacting with the infrastructure. So we're interacting with the virtual infrastructure, so in this case, OpenStack, and there's the end controller. So over here, we're doing things like making sure we're instantiating the security service in the right place based on the policy and the intent. And then we're also interacting with the SDN controller because we're trying to bring the actual insertion, whether it's a simple service security insertion, or it's a bump in the wire, or maybe it's an advanced service function chaining. And then the final piece is doing the elastic scale out of the security. So here the example is if your web store has like 10 web VM and your policy says you want to protect the web VMs using a web application firewall, and you have a web application firewall from certain vendor with a certain policy, and now your storefront needs your application to actually scale up. So you're going from 10 web VMs to 1,000 web VMs. Now, what about your policy which says now you have to go through the web application firewall? So something needs to be able to scale up the security and scale down when it's not needed. And then finally, so sorry about that, I guess change in the, but I'll talk through the two bullets here. So basically, we're enabling the east-west data center security, which is by doing the orchestration, and then we are reducing the threat of the attacks at the SDN and NFV environments. So it's a very high level of what the security controller does. So next, let me talk about a little bit of a conceptual architecture on where it fits in the data center. So this is where multiple virtual environments are being considered. So you have the virtual infrastructure management, whose main function is, this is the OpenStack and the SDN controller on the top. So there's a data center A, which is OpenStack with, let's say, SDN on top. And then you have a data center B, which is the VMware NSX, and then vCenter on the top. And then you have the OpenStack with some Mano or some other layer on the top. And then you have the general compute virtualization and network virtualization, maybe container as a service or something else in the future. So now you have all these different data centers. And at top, you have your security functions, and then which is really something that you've been used to. This is the IPS managers, the firewall managers. And over here also you have the physical appliances. So you can have physical appliances like, for example, you could have like a firewall at the edge of your data center in the north-south, and so on and so forth, right? Now here's where the security controller comes in. So the main function is the security service automation and orchestration. So you're taking all these different virtual IPS, virtual next-gen firewall, virtual web application firewall, virtual application delivery controller. All these are, let's say in the service function catalog, the security controller is coming in, and these are multi-vendor, of course. And this is security controller is coming in and taking that and distributed as a distributed virtual appliance. It's actually doing the orchestration across all these different data centers. So that's the function that it provides. And then the distributed virtual appliance is nothing but a logical entity here that is used to, let's say a single vendor, like a specific vendor's next-gen firewall across all of these data center. And then you're able to centrally manage the policy on this distributed virtual appliance. So what does that give you? It's a very powerful concept, because now the security administrator can take the distributed virtual appliance and manage it, like the security policy it needs across all of these data centers. So if you take it one step further, it's ability to enforce your security policy no matter where your workload is. So that's the ability it brings to the security administrator. So next, let me talk about the technical benefits. I've already covered a few of them, but just real quick. So first is the automated provisioning of the security itself. So this is very important because, as we say, the security is becoming more and more important, and we cannot really live without security in the advance for this type of environment for software defined. A dynamic scale out, I already covered some of that. And then the policy assigned workload. So this is where you're giving the intent at the top. You're able to provide a solution where your policies are still enforced no matter where your workload or applications are being hosted. And then finally, separation of duty. This is where you can use the familiar tools. So a security administrator doesn't have to really get into the network or the DevOps or cloud administrator, but security administrator can use the security controller to describe the policy that he needs for the different workloads, and then the security controller will make sure that it will do it across the multiple data centers. So next, let me walk through like a quick use case. So this use case is, let me just paint it out here. So this use case is, let's say there's a 3 tenants. So three tenants is a finance, HR, and production. Now, if you're a service provider, this could as well be your customer A, B, and C. Okay, and then you have your perimeter firewall, which is the north-south, and then you have your network, which is the public network, right? So now, let's say here's the policy that you want for this type of workload. Let's say for your finance workload, and on the left, by the way, there's a security function catalog, and there are, let's say, 3 different vendors that you want to use, one for firewall, one for ADC, one for IPS. And let's say the policy says that you want to be able to protect the finance workload, and there are 3 layers, of course, web, application, and DB. These are the different VMs in a different layer, tiers we call it. Now this could be subnets or they could be on the same subnet, doesn't matter, but they are the different tiers, and you want to do microsegmentation. Now for the finance workload, let's say you want to be able to provide next-gen firewall inspecting traffic between each of these 3 layers. Okay, the idea is now you are providing a policy called the finance firewall policy, and then you're enforcing that, you know, in between the 3 layers on the finance workload. On the HR, let's say you don't have the need to do actual firewall, but the requirement to be able to protect against application layer attacks. So you want to provide certain signature, you know, IPS type of insertion. So let's say you want to do a bump in the wire insertion for IPS, and you also want a you know, L3 boundary. You know, whenever it goes out of the tenant, all the traffic you still want to go through the firewall. And then let's say for your production workload, because you're exposing this to the internet, in addition to be able to do the microsegmentation at the firewall level, you're also using a web application firewall, which is what the application delivery controller is. And then you're using that to be able to provide you know, the web application front end for your web store or for the web layer. So now how does that happen? So the security controller is going to take all the definitions which are there in the security function catalog for each of these vendors for the 3 different VNF devices we discussed. And then it will interact with the OpenStack and the SDN layer and be able to provide the inner connection into the, so basically it's going to interact with the SDN layer and it's going to interact with the OpenStack and making sure that the policies that we describe are being met. Okay, so let me just quickly walk through a very high level architecture of how we would do this. And I'm just going to paint it real quick. And so let's start with the top level, which is the application itself and the user intent and the policies. And we have the not-binary interface interacting with the security controller, which is where it's going to, you know, take that. This is the policy that we described, right? You know, protect my application with this VNF, with this policy, and so on and so forth. Then we're interacting with the virtualization connector to the virtualization virtual infrastructure. We're interacting with the SDN controller. Again, we are not doing in the SDN controller, we're not really going to do any of the SDN functionality, but if the SDN controller has a SFC API, we're going to use it, or we'll use the lower level API to do the flow programming. And then we're interacting to do the policy mapping with the security function manager, and then also with the agents on the VNF itself. Now the agent is possible to be optional, but if the manager allows you to do certain functionality, then you don't have to go to the agent. So this is the high level I will cover. And then the question is where are we going with this project? So I'm just gonna just quickly show. So whatever I've discussed here is not just an idea. We are working with some prototype, and we are working with certain security vendors and SDN vendors. And moving forward, we want to take it to a proof of concept and working with early adopter customers. And then eventually we want to start working with, you know, build a community for end user SDN and security vendors, and make it like as open source project. And we have some information on this right now on intel.com/OSC, which is the Open Security Controller. And I also like to call out, you know, if anyone's interested in helping out with this project. Again, this was a very, very high level, top level view. You know, there'll be more details on this, you know, available soon. But I just wanted to, you know, if anyone's interested from the community, whether it's a security vendor or the end user, or you know, from a SDN or general from any OpenStack related, you know, I'll be happy to engage with them. And I think that's all I had. Thank you. Any quick questions?
Yeah, I have a question. This open security controller, does it control the backend infrastructure within the OpenStack, like all the OpenStack services, or only is it at the tenant layer? Is it only the security features? Is it only at the tenant layer, or is it in the backend infrastructure?
We can
The
call.
hypervisors.
No, it's not the hypervisor. So it's basically doing yeah.
Tenant layer, okay.
Yeah.
So you're all of the firewall policies and everything. You're
Correct.
adopting at the tenant layer.
Just coordinating and orchestrating it. That's it.
So this tenant layer, it has to be at each tenant we have to install it, this controller, or is it central?
No, you can have a central model. You can have both. You can have central or you can have both.
Okay. And is it a self-managed with the tenant, or is it going to be part of the?
Let's take it offline and take
Yeah.
the question.
You made it. You referred to a security administrator several times, which is kind of the old model, right? Because in the new model with the tenants are the ones that understand their application. I mean, if the finance department needs a high port API open, are you requiring that programmer to go to the security administrator, talk to the security administrator, and say, I need these high ports open, could you do it in the next week or two? Is it that?
No.
How would you imagine the tenant doing?
That's a very good question. So what we're doing is programmatically making all this stuff available.
Okay.
So whether you want to do it through some kind of so we talk about the API, right, where the intent is there, right? So the policy automation is still going to happen. The question is whether the user who is going through it, has some kind of a, now the process may be different. Now that's I think what you're referring to, right? The process may be different, but as far as the automation itself, it will be there.
Right. Maybe some RBAC or something on
Correct.
what the tenant can do.
Correct.
Yeah. Okay. Thanks.
Are you thinking about? Actually, we have to cut it off. We have to cut.
I'll come back.
I was going to say, are you thinking about public or enterprise being the primary?
Um,
So if we can take.
I'll take it off. I'll just come back.
We think